All right. me- yeah. All right. So I guess we can start now.
Yeah, yeah, go ahead.
Yeah. The questions aren't anything. They're nothing too difficult, But
No, no, you think I'll be able to answer? I'll try my best.
yeah, yeah. I guess the first one is like, what part of like mineralogy in general would you say is the most difficult?
Oh, I think it's different for different students. I think that the identification part can be the most difficult because there's no formula you can follow. You just kind of have to kind of plunge in and try to say, all right, well, it has this cleavage or that color, but other minerals can have the same color. It has this hardness. So you really can't follow a formula. Um, but some other people might, say the studying thermodynamics, might be more difficult. So I think it just depends on tastes and talents and experience coming in.
Okay. Yeah, yeah. Do you think like studying mineralogy in like the Fresno Valley area is like I guess the Fresno or Valley area is a good area to study it, or is it just does it not necessarily matter for this field?
Um, I we're lucky to study geology in general in California because there's a lot of stuff that you can see that's near.
Right.
For example, we're very close to the mineralogical, what is it? The California State Mineral and Mining Museum.
Hmm.
And that has just a beautiful collection of minerals, a very nice collection of gold nuggets, the state mineral. Uh, and then in the Sierra Nevada, the mineralogy is pretty simple, but it's easy to find, nice grains of quartz and muscovite and other kinds of minerals. So I, California is a good place to study just because there are so many different things you can see. So
Yeah.
not necessarily Fresno per se. If you go to Death Valley, for example, they have borate minerals, these nice, beautiful, very clear crystals of borate that are found nowhere else in the world. They mine them to
Hmm.
make borax and soap, but they also open it up to mineral collectors to dig through the tailings, and people find like really beautiful specimens. So California has some advantages.
All right. Yeah, definitely. Why did you decide to like teach mineralogy?
It goes hand in hand with other things that I study, like um, volcanoes.
Hmm.
So it usually teaching mineralogy falls to people who do what's called igneous and metamorphic petrology. And so, are you a geology major or
Yeah.
science? Are you geology? Okay.
Yeah.
So
Geology.
you'll be in 101 next spring. And the title of the course is Igneous and Metamorphic Petrology. And igneous
Hmm.
rocks are rocks that are formed by crystallizing magma.
Yeah, of
So
course.
volcanoes are an expression of that. And so most people who study igneous petrology, they spend a lot of time looking at thin sections. The thin sections tend to be rather varied in terms of the mineral abundances. And so it usually falls to us to teach mineralogy as part of kind of a mineralogy petrology sequence, as opposed to somebody who studies, say, hydrogeology.
Hmm.
Um, it, Beth could teach, Miss Dr. Weinman could teach mineralogy if she really wanted to, but she doesn't spend as much time looking at rocks and minerals. So it'd be a little bit more of a challenge. I think Dr. Pluhar could teach mineralogy if he really wanted to, but again, he's not always necessarily looking at rocks and minerals and thin sections.
Hmm. All right. Uh, I guess is there anything that surprised you like the most when you began, I guess, working in this field of mineralogy?
Surprising. Could you? kind of expand on the context. I'm not sure.
I guess like when you're learning about, I like when you're learning about like I guess like mineralogy and like rock identification, was there anything that really like stood out to you or
Well, I guess maybe I'm a Cal State product, and we didn't do a lot of theory. And one of the things that really impressed me when I went into graduate school is how well theory does in explaining stuff.
hmm
And so when I went to Columbia University in New York, I was all of a sudden surrounded by people who spent a lot of time on thermodynamic theory and understood it really well, much better than I did. And I was impressed as I saw how theory could be applied, how powerful it would be to describe things. I think in the Cal State system, when I was educated, people took more of a practical approach to how they thought about science, which is not necessarily bad, practical and theoretical,
yeah.
useful. But I think it was just surprising that how useful certain theory is. There's a reason why we call it theory, um, as opposed to hypothesis.
Yeah. All right. Uh so the next question is like I guess out of like some of the other I guess science fields like I guess like at Fresno State like math, physics, chemistry or like biology, which one would you say would be like the most useful for someone uh studying like uh mineralogy or for them to like take classes on the side like if they were to.
Okay. Um, I would say that probably there'd be a couple of courses, thermodynamics on from the chemistry department would be very useful because they approach it in a different way, and it's good to have that background. And
Hmm.
then differential equations and mathematics, which I was intimidated to take because calculus was a struggle, and I actually found it easier than calculus. It's one of those things where you think, oh, advanced
Uh,
classes, the more advanced it is, the harder it is. Not necessarily. Differential
hmm.
equations is actually pretty easy compared to calculus. Um, I don't know why. It was just more straightforward. There were less theorems to memorize, um, less stuff. Calculus is such a big topic, and differential equations is actually much more narrow. But
Yeah.
it's very, very helpful. And thermodynamics and differential equations kind of go hand in hand because you can use differential equations to solve thermodynamic equations. Or even if you're not solving them, actually, I'm rarely solving them. They're always written in a form where the differential equations class kind of enlightens the thermodynamic side.
All right.
But
Uh,
if you were talking to somebody younger, because I'm 62, I'm old, very old, a younger person would probably say Python.
hmm. I guess this question's kind of broad, but
Okay.
uh, do you think like any like a lot of any like specific skills you can think of from like learning mineralogy that would apply to other fields of in geology?
You can apply mineralogy to pretty much anything in geology because everything reduces to minerals. So,
Hmm.
in the classes you already know, we've talked a lot about groundwater contamination. It's very
Yeah.
practical. It's kind of a problem a lot that the vast majority of the students who graduate will see when they graduate. And it's fundamentally about water quality, but if you put water in contact with minerals, there are reactions that can occur.
Yeah.
Um, so even the things that seem kind of remote, climate change is fundamentally in mineralogy. People look at bits of calcite and in fluid inclusions and pockets of air trapped in ice. So ice and calcite become fundamental to reconstruct past climates, right? The only thing we know, the only way we could possibly know about ancient climate is by looking at the rock record. And at a fundamental level, all rocks are just minerals. So
Yeah.
no matter what corner of geology you look at, there's a mineralogical angle somewhere.
All right. This question is also pretty broad,
Uh-huh.
but I guess. Uh, Looking back on it now, I think I probably could have changed it to a different question, but it's on here, so we'll go with it anyways.
North.
What do you think, I guess, like the biggest difference between like geology and like other science-based studies is not necessarily on like the content, but like I guess like how they go about like what's it called?
Well, I'll tell you a story. When I was at Glendale Community College, I had a professor who told a story about how during World War II, that for data analysis, the armed services looked for geologists to hire to look at data. And that would be data involving stuff that's not necessarily geological, but trying to understand tank movements on the borders of
Hmm.
Belgium and France, or Nazi submarines coming across the Atlantic, or troop movements, or just whatever they needed to look at. Yeah. But they would hire geologists, not physicists, not chemists or engineers, but geologists, because geologists were good in handling really messy data, but still making a decision. Uh,
Hmm.
Physicists and engineers and chemists would um, basically get stuck wanting a very precise solution that just could not be had.
Hmm.
And you have to make a decision. Sometimes those decisions will be wrong, but you want to make the best informed decision in a short period of time using data that's really, really messy. And geologists were especially good at just being able, because they're used to dealing with messy data, uh,
Yeah.
and being able to make a decision that sometimes will be wrong, but hopefully most of the time you're right. And if you've got tanks amassing on the French border, yeah, you can't wait around for the perfect solution. You need a decision. You have to take the data that you have, and you have to make a decision now. And geologists were better at that than people trained in other sciences.
It's really interesting. I didn't know that they had the ask geologists for that kind of analysts.
I didn't really know it either until this one professor who is, of course, World War II age, right? I'm
Hmm.
pretty old, so he must have been a veteran. So he knew this stuff really well. It's something that I kind of wish somebody would write a book about, but maybe I'll do that in retirement. But I just thought it was fascinating.
Yeah. Uh, I know I wrote it down, but I guess the question changed back. But those
Mhm.
machines, the XDR, like the ones that like that we used like for like one day that analyze the minerals.
X-ray diffraction.
Yeah, exactly. Would you say like I guess like at least like a basic knowledge of chemistry would be useful for using that, or like would it not necessarily matter?
Um, for using the instrument, it's really about knowing the software in terms of
Hmm.
interpreting the data. It's as much about mineralogy. And then in terms of the theory of how it works, it's probably as much physics as anything. So the chemistry angle would really be about using your knowledge of chemistry to interpret which minerals are valid. So you got to use it once, right?
Yeah.
You got the data. The computer says, oh, here's a perfect fit, and it gives you these really obscure minerals. But if you look at their chemistry, for example, one mineral might be dominated by beryllium, but you don't have a beryllium rich system. You have a system that has probably no beryllium in it, and so you know to ignore that mineral and choose the one that's dominated by silicon and aluminum.
Yeah.
That's really kind of where the knowledge of chemistry comes in.
All right. This is the last question. It's also pretty broad, but
Mhm.
would you say like I guess chemistry would be useful for like just in gen not necessarily just in mineralogy, but just like other fields of geology? Would you say that would be kind of useful?
Oh, yeah, yeah, yeah. I mean, what I do is called geochemistry, as well as mineralogy. So geochemistry, thermodynamics, mineralogy, they kind of all overlap. And one of the most well-known geochemists is a guy who passed away recently at MIT, but really did a lot of really foundational work. His background was chemistry. He got a degree in chemistry first, and then moved into geology as a graduate student.
Hmm.
Uh, And chemistry is really foundational for a lot of climate science. That's really a lot of geochemistry. So, yeah, in terms of the chemistry itself, coming back to another question you asked, inorganic chemistry would be really useful to somebody who wanted to do climate change or igneous petrology, geochemistry. Inorganic chemistry is really useful. And we're doing some of it actually in mineralogy.
Yeah. Thank
Because,
you.
yeah,
Oh,
you're welcome.
uh, uh,
Which class is this for? Is this for,
Chem 1B.
okay.